Assalamu alaikum and welcome everybody. Today we want to introduce you to the last or the third type of intermolecular forces, which is hydrogen bonding. So we just noticed that hydrogen bond is a type of interactions that takes place between molecules. But in this case, these molecules must have some conditions. You never find hydrogen bonding in all molecules like van der Waal or the temporary dipole. Hydrogen bonding is a special property for some compounds or let's say for some molecules. So what are these factors or let's say conditions to have hydrogen bond? So first of all, you should have hydrogen bond because it's hydrogen bonding, yeah. This hydrogen bond is connected to the most three electronegative atoms in the periodic table, which are fluorine, oxygen, or nitrogen. In this case, as we can see, the hydrogen here are partially positive. These are partially positive. And you know the electronegative atoms are always partially negative. So this is the first condition, a hydrogen bond that is covalently bonded to one of the most electronegative atoms in the periodic table. This is condition number one. What about condition number two? We will have these electronegative atoms, which could be fluorine, could be nitrogen, and could be oxygen. You notice that these electronegative atoms have lone pairs. So these are in the second molecule. The attraction will be between these molecules, in this area of hydrogen and the area of electronegative atom, which is maybe fluorine, nitrogen, or oxygen. So the interactions will become in this area. So, as you can see, we have partially negative, electronegative atoms. We have hydrogens in the middle. We have electronegative atoms, on the other side. Where is the hydrogen bonding? The hydrogen bonding is represented by dotted line. And as we can see, the angle between the dotted line and the covalent bond is 180 degrees. How can I apply this, let's say, and take some examples? Let's go and take another example. Let's draw like ammonia and H3. Okay, if we want to see if ammonia, let's say, contains hydrogen bonding with its molecule, I will draw ammonia as we can see in here. Okay, and we just remember ammonia has a shape of trigonal pyramidal. It has lone pair as we can see. And we will make another nitrogen atom. It has 3 hydrogens, as we can see. It has 2 lone pairs. Where can I draw hydrogens? First of all, you have 2 molecules. You have molecule number 1, and this is molecule number 2. Okay, the first condition says one of the hydrogens must be connected to the most electronegative atoms. I have hydrogen, good, and it's connected to nitrogen, which is one of the most electronegative atoms. So condition number 1 is done. What about condition number 2? Do I have one of these electronegative atoms, which is nitrogen, fluorine, or oxygen? Yeah, I have. So we will make a bond between nitrogen and hydrogen in this way. You draw the dotted line, and you have to put in your mind the angle between the covalent bond and the dotted line is 180 degrees. Not like this. We want to, it's not enough. Nitrogen is electronegative, which is partially negative. Hydrogen is partially positive. Nitrogen is partially negative. So in this case, I can do it. And I'm happy to draw hydrogen bonding between ammonia molecules. Can I draw hydrogen bonding between 2 different molecules? Of course, yeah. How? Let's take, let's say, water molecule. All right, and let's take another molecule like ammonia. It's really good. Why not? First, I will draw oxygen. That is combined to water molecule. I will draw water molecule, and it's connected to hydrogen. We have 2 lone pairs in water molecule, and we have another hydrogen here. Okay, and then I will draw ammonia. as we can see, ammonia will be drawn like this. We have hydrogen, hydrogen, and we have another hydrogen. Here we have lone pairs, and let's take that. As we can see, do we have hydrogen bond? Do we have hydrogen that is bonded covalently to oxygen or to electronegative atom? Yeah, that's good. That's it. And do I have another electronegative atom? I mean, one of these three? Yeah, I have in the other molecule. In this case, we can draw the hydrogen bonding in this way. Okay, this is the dotted line. Okay, but you have to fill these dots. This is partially negative. This is partially positive. This is partially negative. The angle is 180 degrees Celsius. Not Celsius, 180 degrees. Okay. Can I draw hydrogen bonding between something else like HF? Of course, yeah. Let's draw it with water molecule as well. We have H2O and HF. Okay, I will draw H. Okay, that is bonded to fluorine. On the other hand, I will draw oxygen. Okay, and we have another hydrogen. Okay, I have hydrogen that is covalently bonded to one of the most electronegative atoms. Yes, this is partially positive. This is partially negative. This is partially negative. So there will be a bond between them. I will draw them like a dotted line. The angle is 180 degrees. Let's take another example. Let's take like CH3, C double bond O, and we have H. By the way, this is called ethanol. You will take it in organic chemistry later on. And I have water molecule and H2O. Can I make a hydrogen bond? Let's see. Do I have hydrogen that is bonded to one of the most electronegative atoms? Yeah, I have. This is hydrogen. This is partially positive. This is partially negative. Do I have another oxygen? Yeah, I have oxygen in here. So you can arrange it to be, let's say, fit your, let's say, drawing in here. CH3, and we have H. There will be a bond between these. We have 180 degrees. So this is hydrogen bonding. Okay, we're done.